just enough food to not trigger your body into thinking that it's eating.
Okay.
But
I've been on a keto
I
diet
gained
for
40
5
pounds
weeks.
during COVID. What?
I've been on a keto diet since for coming up 6 weeks now.
Yeah.
It's been
All
great.
meat all the time.
All meat all the time. That part is horrible. I can't wait till my next meal of chicken. But yeah, it has been great. I lost a lot of weight.
Yeah,
So
you got the energy boost from it too.
yeah, I feel a lot better, but I'm not sure if that's just from eating nutritious food regularly or what. So yeah, I'm not sure if I have the energy boost, but I certainly don't have the carb lag anymore.
Right.
So there's that. Yeah. Yeah. What I've done is I made a markdown document of the schemas that I plan to use in the redoing of the model system.
Okay. Those are up on the docs.
I posted a link to them. They're actually only in the repo because I use the markdown document to auto-generate the schemas from, and so I need it in the interblock repo, whereas the docs are in a website repo. And because it's hard to link across repos, here we are. Let me send you the link in the protocol chat room.
Gotta get my two factors going here.
That should be, what do you need that for? It should be open, public.
Yeah, I just want to log in.
Oh, okay. It's a strange desire that humans have to be logged in.
to belong.
To be recognized, to pass the test.
I have links like in my user dashboard to things, so I was going to go that way, but you sent the link at the same time.
Oh, right. Okay, cool. So one of the tools that gets supplied with IPLD is something that can extract schema definitions from a markdown doc that allows me to waffle endlessly in the markdown doc and then just type in the code for the schema and then extract it out so that it's nice to read as well as the actual meat of the system. Where to start? I think the most major change I can think of is that I've modified the covenant system. I have decided, and I'd like to check with you if you can see any holes in it, that remember how covenants we never really tightly defined what they were. I mean, we got to the point where it's like, okay, it's an npm package, fine. Npm package has a hash. It's probably got a name and a version and all that. What I have defined a covenant as now is that it is defined by a chain ID and a pulse ID. Okay. And so that when you publish your code, you first have to generate a pulse chain, and then you have to publish your version of your code that makes a new pulse in the pulse chain. And the package, if there is one, needs to be attached as the binary of that pulse. And so what it means is that you can allow versioning as you go along. It's kind of backwards compatible with NPM. You can attach Git repos and all that to the pulse as like children or links. It basically allows a much cleaner way to deal with covenants and the evolution of code than just specifying, hey, here's a hash of a package. It's like, well, where's the rest of it? It also means that all your code is basically self-published. So if we make the covenant for publishing covenants with kind of looks like GitHub/npm already, then it's like a self-contained thing, and you ran the site inside of the package instead of putting the package onto the site.
Right. Yeah, that makes sense to me.
Okay, and in dev mode, what I do is I'll override, because there's the chain ID in there that specifies what the covenant is. If you're in dev mode, I'll override the lookup for the covenant based on the chain ID and use the live functions that you've provided from your source code. So that when you're in dev mode, you're running live code that you're editing, sort of hot reloading as you type of thing.
But you're still running it through all of the like chain mechanisms.
Yeah, it's just that when the isolation mechanism gets to the point where it has to select the reducer to run, it will swap it out for a preloaded function which comes from your developer source, as opposed to the package that it gets that would otherwise be loaded.
Right.
I've also think it's a good idea to publish the system covenants, or the sort of the standard library, as it were, in the same fashion, where we just generate a chain ID and then publish the system or standard library type covenants like datum, collection, shell, other such things. They just get loaded just as though they were a user covenant. Who really cares? And then ultimately, Interpulse itself, the library, in the config section of the contents of the pulse, I have placed an area that references the covenant chain of the Interpulse software that you're intending to run the thing that's being run right now.
Right.
So Interpulse itself is specified in the same way as to which version your code expects to be running, and then also all the system or standard library functions are referenced in that same way and updated in that same way, and user code is written in that same way. And so you don't need any credentials whatsoever, and you can publish a globally accessible code package, provided someone knows the hash.
Right. One thing I have a question about here, if this is meant to be like a bit of a replacement for like a package file in something like package.json.
It's meant to be a wrapper.
Yeah.
There's
this question of dependencies where, like, I know that when I call library code, like, I think this is something I tried to ask about before, but I didn't ask it in a very clear way. There's two different ways of doing dependencies now, right? Like, dependencies can be imported into my code, like, and then all packaged up as one package and then deployed to one chain. But dependencies can also be my chain calling to other chains.
Yeah, I know exactly what you mean. Definitely for the initial launch, it's just it's blunt, right? It's just all your dependencies get npm installed, and then we run that. But the idea is that each dependency we would republish as a wrapped chain, and then you would be able to call each individual image as a binary, and so that you got sort of instant reuse. And so we'd present a sort of a file system and user space type view to node modules, where it's actually backed by all these different links out to wrapping chains, some of which we wrapped, others which were published native on this system. And so the install time ought to be like, near zero, because it's just images, and you're like, it only really fetches blocks once the application needs it on the file system.
Mm-hmm. Yeah, no, I really like that. I really think that the end goal here is to try and embed the module system in the chain topology.
Yeah, absolutely.
But yeah, I like the fact that it can be a little bit looser than that. Like you can run with your JavaScript dependencies right now, and we can I like the idea of us going and pulling the things that conform to the interface and making them into chains themselves.
Well, what I want to be able to supply is a service where you pay to receive forked and audited versions of open source software, where it's like, yes, these people publish them, but we don't republish them until they've passed audit from a pool of auditors, and you pay money into this pool to get the guarantee that the code is safe and secure, and no one's going to push something up that sort of rug pulls you, I guess. And then that also allows an attribution stream of money to flow back to the original authors, because of our ability to airdrop to anyone.
Right.
Which I think is a useful thing, actually.
I think the challenge you'll run into with it is code needs to be written in a specific way to function in this system.
No? Well, I mean,
you need to provide I don't know. I mean, I can imagine there's other ways of writing it than reducers. Xstate seems to be a really good example, but it needs to respond to some kind of RPC call, basically, and it needs to do it in a pure.
Sorry.
It needs to do it in a pure and deterministic way, and not all libraries are written like that.
Right. So, if you want to be native, then you need to export something that conforms to our interface, which we can test for, and we can error on if it doesn't. But if you don't, we can actually easily wrap you, because I mean, all programming languages use functions. Functions can be mapped to actions with payloads, where the payloads are just the args. So if you provide us with a package that is non-conformant, we can wrap it. If you need side effects, we can give you side effect access, wrap your interface, and then call it from chainland. If you sort of imagine that you shouldn't need side effects, we offer the pragmatic solution of, well, if side effects happen in the woods and no one's around to hear it, did they really happen? So we're just we put you in a big cast iron box, side effect away. At the end, we're like, nothing got out, so therefore it's pure, yay. And on we go. Which is good enough, man. I mean,
I guess. I mean, there might be some shim piece there that's worth focusing on, soon, like an FFI kind of thing. That would be a chain that has the express purpose of calling down to native languages and providing that interface for them.
Yeah, I just I want to focus on JavaScript first, because it runs in the browser, and so you can touch the users straight away. Plus, any other language that you run is going to need a browser. You can give a browser interface to a Python program very simply in the system by writing your covenants and your reducers in Python, and then you just use our front end libraries to let people navigate the JSON that was produced from that function, and you're kind of off. Plus, it allows these chains actually allow us to make cross-language calls pretty simply. Like,
right.
Once we're up and running, we shouldn't actually care what language your reducer was written in. All that matters is that, yeah. And so I like it as a nice standard way to interface with many different libraries and many different languages. I think it's
it jumped out. It jumped out to me here on the covenant description on this page that like the one thing you miss by saying package binary is like that doesn't specify anything about what needs to happen inside the package at all. Binary just means
that's covered by type. So like the package you need to tell us what type of package it is, and so that we know what to do with it. Like, is it right? Like,
that's what the package state is, or
no, the package types was supposed to be.
I see. Okay.
Because we need to know that so that we can, first of all, know if we support it, and second of all, we call a different environment in the isolator depending on what language you gave us.
I love the idea of proxying like every language into the browser through this. I think that's a really good idea.
It's easy to do. I mean, I think I'm starting to appreciate more it's the interface that we have that is probably the more useful thing. Just this whole action to function in a blockchain that you can browse can be used in a lot of neat ways.
Yeah. Nice. Only one type of timestamp, ISO dates.
Well, you can derive all the others from it. So, and given the delays between validators and the time it takes to sign, it actually doesn't make sense to go more higher res than that. So
I wish people would stop defining data formats. I lost 17. A half day to it this week again. So what else? Keep going. Let's go.
Okay.
Do you think that we need to keep talking about covenant?
If you're happy with it, I'm more than happy with it.
No, I love it. I think like the idea that the package state type is basically just a package.json is such a clear way of explaining the concept.
Yeah. And then it's the way that, because we can have these links that go sort of in between blocks and define your own tree based on your history, you can just present things like the state tree or, the binary, make binaries look like a file system, even though they're in like miles away, relatively speaking. So it's been quite liberating actually, having IPLD define unequivocally what links are and how they work has been liberating.
Yeah, I mean you have a native pointer concept that's well developed and battle hardened against distributed data structures.
Yeah, battle hardened hard. Okay, probably the most. Sorry.
A pointer is the most important concept in programming. Like, if you have a pointer, you can do like a bajillion things from there.
I don't know enough about programming to argue with you, but it sounds about right.
One other thing jumped out to me here. This looks like it kind of discourages reuse of the same binary in a way that like I might be running two chains in parallel that are technically referencing the same bundle, basically.
Yeah.
Because the bundle has to have the metadata about the specific chain that it's running on and the specific pulse that it was applied on.
You talking about the covenant system? And you're saying
So
that the you can block deduplication because the pulse is specific. I
what I'm
think.
saying is like the build, the binary, the package, whatever you want to call it,
Yeah, yeah,
like that thing, like in kind of normal library semantics, that thing would be loaded in many different contexts and run in many
yeah.
different contexts and like and be capable of building communication, I guess, on top of that because it knows all the other instances that are running. But in our case, like it really looks like that binary like needs to be manually um, what am I trying to say here? I'm really fumbling it. um, like I had originally thought of covenants as being more like actual npm packages where you load them from the same
Yeah, yeah.
URL
So
on
in this system, a binary would be a npm package for JavaScript.
right. So we're not losing the legacy like URL addressing and being able to pull this binary in.
No, absolutely not.
Because yeah,
It uses the within the package state. It figures out what the package type is. If you said it's JavaScript, then I know that the binary has to be a npm package. I have a loader for that. I know how to make an isolated little area, run the npm install, pull it in off the network, and then create an image that represents what's going to get loaded each time I want to run the reducer from it.
right.
One of the daydreams I had about this covenant system is that you can do that build or that install and present it as part of the chain in a way that you can allow for people to publish just source and then have like trusted builders or installers do an install so that you know that the source matches the running binary insofar as you trust this intermediary more than you trust a random person.
Right.
So it means that I can push my source code and have my build scripts run by someone who's trusted, so that people can consume it with a little bit of extra security that they know that it was actually generated from this source code according to the trustworthiness of this bonded executor.
Yeah, that makes sense.
Um,
Uh, is there any way for me to like later in the game reference like the code that's running on a foreign chain for installation in my chain without going all the way back out to the binary universe, I guess. That might be the question. Because like in the spirit
so
of like
you want
eventually
to deduplicate. So you want one chain to be able to use the binary that was already loaded and running for another chain, right?
yes.
That absolutely is what I expect to happen. But it would be up to each validator to choose how they want to do it. Do they want to pull in the pre-installed version offered of the package, or do they want to run the install themselves and run it? It's entirely up to them.
Right.
If
Right.
you
And I guess you want to leave that for
if you if you are a validator and you see another chain that's running asks to be run by a covenant that you have already loaded, you I imagine we would design it to automatically attempt to use that already loaded image as opposed to
right.
making a new one. In which case I realized I need to modify this to allow greater than or equal to on the pulse reference, so that you can say, well, yes, I wanted this specific pulse or any later pulse. So I'll take any upgrades, so that people can sort of find approximate fit, I guess.
Right. Yeah. I mean, that all checks out to me.
But there's just a world of I was quite pleased with this because it sort of solves a world of problems that we'd been kicking around the schoolyard for a while, and it ultimately has this innate self-publishing notion about it. It's like, you are npm now, you can publish
Right.
with just as much power as them. You can make private packages trivially because you just published and set permissions on your chain.
Right. Yeah. I mean, controlling the replication, like from one chain, like across boxes, and then the replication out to other chains, that like allows you pretty fine grained control over like what version of reality you're seeing
Yeah,
in terms of what software is running.
Yeah, and so I am pleased with this system because I cannot see anything wrong with it. It solves a lot of previous problems that we didn't have a good fix for. It feels simple, and it also feels upgradable or expandable in the future. Yeah.
So it's not. Okay, never mind. I'm just reading answers to questions that are in the text already. So
Yeah, I guess that was the major change. I'm glad you don't find anything too stinky about it. That's because changing that's annoying once it's built. I never did solve it before now, so I'm glad to have something that sort of sits well with me. Okay. Oh, sorry.
I guess my migration would all still work the same, right?
Totally.
Yeah.
Probably the next major alteration is under the TX heading. This is taking on board your feedback about not muxing every alias, but definitely splitting system and covenant.
Right.
I'm probably going to rename covenant into reducer because covenant's less accurate.
Right.
The two new concepts I think I've introduced are the concept of an action having a counter on it. So referring to a channel and a number gives you a permanent reference to a request or a reply.
You should expand these, like in your example, you should expand the actions to and the replies to have data in them, so it's more clear.
Okay.
Like what type of metadata is in there to like.
Oh, right. Okay. The second concept I've introduced is this idea of tracking what promises were made to you, because otherwise, like the database query to figure that out could potentially span the entire chain. So
That's not good.
No, so it's like it seemed like a DDoS, a way to just sort of drown chains if you were being malicious about it. And then in the previous implementation, I was tracking the promises on each side of the channel. But now with linked data, I'm like, might as well just be the same piece.
Right.
And so basically, sorry.
If somebody else promised it, like you're definitely getting that slice of the state, right?
Yeah.
Because that's how the transmission protocol actually works. So
yeah. So, but it's designed so that, I mean, the reducer is treated as evil, basically, and stupid, malicious, and all those kinds of things. The chain or the system running above it is meant to keep it respectable in the eyes of the other chains. So, for example, a reducer should not promise twice. It should not resolve twice or more. And so the first place where that errors is locally. I will locally throw if you promise twice, or you try and resolve twice, or if you try and resolve out of order. So try and resolve something that's ahead of yourself. The idea is you must process your actions one at a time in order. And if you reply to the future, you'll get kicked out of the runtime.
But order is defined by the system slice, right?
Yeah.
Like, because we don't want to allow one chain to congest another.
The congestion mechanism is slightly different in hash-linked data. Right now there is no congestion control, but remember we spent some time talking about how to select the next channel to process and the next action to process, and
the tornado thing, right?
Yeah, the tornado thing, and you kind of, that is a form of congestion control.
Mm-hmm.
You sort of don't care about how many interpulses pile up on a channel to be processed. All you care about is how many get run through the reducer and which ones. That's where flow control is important. Linked data means that you don't care how many things the other side sends you. Your choke mechanisms for receiving the hashed data are what stops you getting flooded, and apart from that, you don't care because you just add these things in to the pool.
Right. But it's more about if I have two chains talking to me, I assume I'm always digesting it's FIFO, right? When another chain publishes to me, it's first in, first out. I would want to eat the first thing that it sent first, the second thing that it sent second, the third thing that it sent third.
On a direct chain-to-chain basis, it is FIFO, absolutely.
Yeah.
And it's also the only time when that changes is that promises are returned in the order that the resolver resolved them.
Right.
So if I resolve promise 10 and then I resolve promise 9, that's the order that the promises will be resolved on the other side too.
Okay.
But when I had to say that I was going to get back to them later during the FIFO processing. The FIFO processing is you have to process by FIFO and reply by FIFO. You can't reply anything but.
But what about draining across incoming chains, basically? I still don't know that I understand what you said. So, if I have 5 chains and one sent me 40 requests and one sent me 1 and another one sent me 1,
oh, right, yeah. At the moment, I'm doing FIFO in the chain and also FIFO per chain because I am not yet ready to handle maliciousness. But in the next iteration of flow control needs to be like an onion sort of a ring, so that one of the properties that the DMZ needs to hold is that it acts as both a snapshot of it is a pulse. It also acts as the pooling object. So as new interpulses come in, the DMZ is modified to support them. The critical thing is that it needs to be modified in a way that is entirely additive. So I can be at a certain point in let's just call it the soft pulse. I can begin blocking on that, where blocking is processing some channels, 0 or more channels, and then snapshotting the output. And then during that blocking process, while more pooling was happening, I can easily transform my new block into the modified soft block without backtracking at all. And so what that starts to cause is an onion-like structure that appears each time the chains were interpulsed up to a certain amount. And so the flow control should process one ring at a time. So you process this ring, and the otherwise it's like the chain with the lowest ID is going to always be processed first, and everything else, it's like when you begin blocking, you take the current hash-based snapshot of the pool that represents a snapshot in time. You should drain everything in that first before you begin the next snapshot in time.
Right. Yeah, I get what you're saying. So it's about demarking, like firmly putting actions as belonging in one moment in time or another.
Yeah, as being part of one pool snapshot or another, even if they're from the same chain, because like one of the attacks we need to avoid with that is that the proposer, you want to take as much freedom off the proposer as you can, because the proposer can jiggle with the order of channels and the order of arriving into blocks to make some outcome that they may care about. Like if it's a card game or some other kind of gambling scenario, they might alter what they chose to make the next block from by deferring some other actions that could be to their advantage. Who knows? So that's why that tornado part is important, but just not now. That's all.
Yeah, that makes sense. And again, you can get pretty far, I think, probably by just being careful about like processing things in snapshot order. That feels like it solves the problem halfway already.
Yeah, I think that goes a long way. And then the other half of that solution is having the validators agree on the pool ahead of time, so before blocking, so they can actually sort of early reject if they're like, no, you've missed out some actions on purpose. I'm rejecting your block because that's not what the pool said. So but this is actually the only place in the system now where it sort of looks like an actual blockchain, is the link between precedent. And one of the important things to note in how precedent works is that it intentionally tries to hide how many blocks the other chain made since the last time it talked to you. So from your
how so?
Because there's no height anymore.
So precedent is just a hash, basically.
Precedent is appointed to a pulse, which is the last pulse that you were transmitted to from. And ideally, you would have no way of determining how many or how few pulses occurred in between until your next one. You're supposed to be blinded to the activities in the chain, the metadata that you are not allowed to access.
Yeah, I actually think that's a really important principle now that I think about it. Like getting height from the other chain would allow you to infer a lot about its behavior, right?
Yeah, it's very telling. And also in the way that we so you'll notice that the transmissions, I actually take them at the end of a block making cycle. I take them and present them on a dedicated slice at the base of the DMZ. So I take them out of the network object and put them in their own slice so that I can begin to give privacy between channels. Because the trouble is that if I somehow gain access to what someone else's channel was, and then I also in the future get what I'm supposed to have, which includes the Merkle tree of what my neighboring channels were as well, I might be able to brute force what the actions were, particularly if they're simple, like a yes or no, and I can just grind to see when the hashes match, so I can sort of deduce something, right? So the idea is I move each transmission, each TX object to its own object in the base, and I will inject some pseudo randomness in there to make it so that you can't actually, you have no idea how many neighbors you have. You've got no idea what they changed to, what they said, or anything like that. You're properly blind to everything else that happened in the chain except what you're entitled to.
How are you going to seed the pseudo-random?
I'm glad you asked. Under the config section, there is an initial seed that is supplied with each Genesis block.
Oh, cool.
Each time you call our custom randomness getter, we will increment the pseudo randomness by 1. So we'll give you the next piece of pseudo randomness and then store that on the chain so that we can provide the reducer with some reproducible randomness, and we can also use that for our security operations, because so long as you never knew the original seed, you wouldn't know the pseudo's randomness that we generated from it either.
Right.
Yeah.
I like that pseudo-randomness is actually helpful here instead of
Really
harmful.
Really helpful, yeah. Because it needs to be predictable as well, right? And so you need to use that same pseudo randomness for when a chain makes a child and it wants to seed the randomness of the child. It draws on its own pseudo randomness to give the next iteration of that, which it sort of pushes down into the chain. So provided you never knew the original, you should be good. I don't know enough about randomness to say that it's safe, but all I was planning to do was say it would be original seed, and then I would hash it. Then I would take the original seed plus that hash and then hash it again. And so each time, like, you never knew what the original seed was, I'm giving you a new hash each time. You can't predict what the next hash would be. I think that works. And yet, if I told you the seed plus a count, you would arrive at the same value, which is sort of all the function needs to do. I'm not sure if that's secure. I know that there are secure ways to do this. The point is the principles there, we're aware of it, and we've sort of designed the system to have a nice jack point for solving those kinds of problems.
Right. Yeah. I mean, it's all wrapped up in a structure.
Yeah.
Yeah. I mean, I couldn't honestly tell you.
What I'm aiming for is that during testing, the chain IDs all come out the same, because I can supply the same seed during testing, because reading ever-changing chain IDs during different Jest test runs is fucking annoying.
Yeah, no doubt. I thought there was a way we figured out before where you could like harness everything, calling every chain by its alias, basically.
It's still
in dev, but
yes. So the debugger, the sort of the block printer that I made, it does do that, but it helps to also know or have predictable pulse hashes too, because you know something went different if you're like expecting pulse number 5 to have a certain hash and it's off, and you're like, oh, not my intention.
Yeah, no, that's a great red flag for like stopping a test right away in a lot of cases, right?
Yeah. So I'm hoping that just like you can have like how Jest does their snapshots of UI elements, I'd sort of hope to use that same system for like the hash of the blocks during this test run should match the last snapshot that we took of it, or something's gone wrong.
Yeah, so that's like a like mathematical approach to purity testing, is like hash diffs when they pop up, like your code might not be pure.
Yeah.
Um, but that's not as good as property testing or like actually going through and doing a like a proof that your algorithm is pure.
Look, I go less and less. I think those things are a waste of time. So if you can guarantee no side effects got out of the box, fuck, who
Yeah,
cares? Just like,
yeah,
I,
I'm with you. I like the idea that the state is just on the other side of it, and like the thing the validators care about is the state, and
yeah,
like who cares what happened on the inside, right?
yeah, like go for your life, do whatever you want. It's sort of your problem. Like,
Right? You're gonna turn the network off inside, right?
yeah,
So like there's no way you can leak shit.
no.
Like if you want to write code that like uses math.random, I mean go ahead.
Well, we override some, per language, we'll override some useful functions like date.now, math.random, um, and we'll use that randomness mechanism that I talked about before to give you successive calls, will give you different pieces of randomness that you can then use.
Right.
And date.now will give you the timestamp from the timestamp item that you saw. So you have a sense of time in your when you're running. Uh, you should be good. I mean, what else do you want? I told you what time it is, and I gave you something random. Go for your life.
Data now I assume is going to be overridden to supply the like the block time, pulse time.
Yeah. So the soft pulse. When you start blocking it, you set a timestamp. When the validators go to validate it, they have some agreed delta that they're like, your timestamp is within the last 2 minutes, so we'll allow it. And then that was what the time was, as far as anyone knows.
That's all it can be, right? I mean,
Yeah,
it's if you use anything other than that, it's problematic.
yeah, yeah. We're not trying to
Um,
be an NTP server.
I mean, we
We,
kind of are.
yeah, but we're more concerned with sequence than we are with the time.
Sequence and what happened in the sequence, which I
Yeah,
mean, in a metaphysical way, is a way of describing time.
I know.
Time is the common variable underneath all of the different measurements, right?
Mm.
All of the different perspectives. Anyway, let's not do metaphysics. Um, I love that pulse is like just ridiculously simple. I love that. I love looking at
Yeah,
that because it's like it's such an answer to like so many questions that I had over the years.
and it's like two
Like
lines,
it's
right?
right. You have like you have some signatures and you have the well provenance is what is the like the hashes from all the various pieces, right?
Provenance. So you have the DMZ. I love the name that you chose, DMZ. I almost called it pulse contents, but then I changed it back yesterday because it is the demilitarized zone. It's where the reducer and the system meet and interact. um,
Right.
uh, so the the provenance is answers the question, where did the DMZ come from? Where did this DMZ come from? And so it's
Right.
basically all the this would, in blockchain terms, this would be simply the reference to the parent. But because we have these trees at our disposal, I find the trees far more useful. Plus, we also have restraints. Like a blockchain cares about only one chain. We care about millions. And what's more, we allow them to fork and then merge again as well. And so we need a tree structure to track that. Plus, the the costs of um, one of the key functions of the communications network is announce. The way that DHTs work in the way that PubSub works in a peer-to-peer way, particularly in libp2p, it's very expensive to have a large number of topics to subscribe to. It's much cheaper to have a single topic with many different messages. And so,
Right.
yeah, so having the pulse tree, the pulse tree allows you to just get the latest pulse, and then if you wanted a specific block height, you use the trees to go backwards quickly. Whereas if it was a chain, going backwards is a function of how many pulses have been made between what you want and where you are now. And so the tree is, sorry, I mentioned the announce thing. That's slightly off topic for now, sorry. The tree is simply there because of the expense of doing queries for height in the peer-to-peer network is too high. So doing a query for latest is pretty cheap. If you have latest, the tree gives you rapid access to any height, as opposed to having to walk.
Right. The tree is it's the Merkle tree, right?
That's the Merkle tree. I haven't the time to do anything fancy like make it a trickle dag or even anything other than it'll just be a balanced Merkle tree for now.
Yeah. That makes sense.
The state tree is something I hold dear. The state tree basically makes the chain complex look like a big MongoDB. And so
just a giant binary blob, eh?
Yeah, and it's a tree that skips or shortcuts all of the DMZs in the tree and just walks from child state to child state. This is the thing that if you did a whole bunch of activity in the system only, but you didn't change the state of the children in any way, the state tree would remain unchanged.
Right. Do you have that typed out?
The state tree, yeah. That's just in just above provenance under DMZ.
Right.
Sorry, I haven't moved it down. I need to move it down. I made the distinction that provenance was where did the DMZ come from, but I didn't move. It used to be in the DMZ, and then I changed it.
Right.
So I need to modify that. Turnovers is for now I'm just going to make it a list, but it needs to be a tree for the same reasons that lineage needs to be a tree, and that you need to be able to do lookups quickly. Turnovers it's considered a turnover block if the validators agreed to change the validator set or the quorum threshold. And so turnovers is the list of all of the blocks where the validator set was altered in some way. And so that when you have a chain ID, you need to grab all of the turnover blocks to know that the current latest you're being given is authentic from you need to trace the provenance of the latest thing you got back to the genesis using the turnovers to be able to be sure that the signature, the validator set didn't change.
Right. It's validating the validators.
Yeah, that's what turnovers is about. But I guess those are the only major changes to the system.
It's pretty crazy that there's that few.
I know.
and they're actually all really good. Like they all make things smaller and easier to understand.
So much smaller, so much easier. Maybe the only two real sleight of hand things that I've done here are that address is not a address is a raw type. Address is just another name for a link. So that was a bit special. I also made the distinction that I'm going to make addresses be version 0 CIDs in the IPLD format, because they're instantly, you can look at it and be like, it starts with QM and it's like shorter than the other ones. So when you're dealing with like a pulse address or a chain ID, it's obvious which one you're looking at.
Right. So address is address is the thing that's backing communication between chains.
Well, yeah, it's the version 0 content ID of the Genesis provenance.
Right. Sorry, scanning down to provenance, I saw ACL, and I saw inside of ACL it says future, which I think has been the state of ACL for as long as I've ever worked on this.
Yeah, it's just I haven't needed it. That's the only reason. It's been very helpful to actually have a task to do in terms of building the CRM or building the Dreamcatcher pooling. Honestly, ACL just hasn't been needed yet. That's all. When it does come to be needed, I'm pretty sure I can just copy Linux almost directly, where the permissions of each individual chain are stored with the chain, and then there's an object that's part of the chain complex that acts like some like etc password type of thing, which says who belongs to what groups, what rights they have, and all that. If you're speaking, I can't hear you.
No, I'm not. I'm reading. Sorry.
Sorry.
It's real scintillating content for YouTube. Me squinting at a screen. So provenance almost is the block, basically.
No. Provenance is still one layer above the block. The DMZ is really the block, the bit of the block that everyone cares about.
Right. I guess it doesn't really make sense to even think about the block anymore. Like, this feels like such a I mean, it's the same, but it's so different, you know?
I know, man. It's so different, and it's so much nicer. Like, it's different in a clean, reusable, compact. It's so well defined because of the work the IPLD guys have done. It just makes it so clear.
I suppose all the ands and the types here just means this is by reference and not by value.
Yeah, so the and means that it's actually a CID link, so that it is pointing to a hash, and you need to go out and find the data that backs that hash. But the fact that there's an and then a type is a way of indicating that it is a link, but when you resolve the link, I expect this type to be at the end of that link.
Right. So it's not just a reference, it's type checking too.
Yeah, it's type check reference. Yeah.
So what is the type checking mechanism actually like? Like, is it just conforms to like JSON schema kind of thing?
Yeah, it's very simple and very fast. It's basically just does your JSON object exactly match the schema?
Right.
It's kind of
That makes sense.
yeah, that's what you get.
Mhm.
It's nice though, and yeah, I think it was a folly of me to make the previous model system try to define the classes automatically based on the schema. Here, I've made it way looser, so it's much less work for me to define these models than the last one because I spent so long making the general auto class maker when I could have spent that time just making each individual class.
Yeah, well, that's the eternal programming problem. Do I
programmed too
automate my
much.
work before I
Yeah,
do I
my bad. I programmed too much.
do I automate my work before I start it, or do I automate it after?
That is the lesson I continually have to learn. And every time it seems to be automate after.
Oh, of course, because if you automate it first, you made the wrong thing. Guaranteed, every time.
Every time. Every time.
Uh, what's the syntax and reply here? The reject, promise, resolve in the sum type,
Huh?
the enum type, like the function call syntax you're using.
Oh, that just says that under the hood, instead of using a string named, say, reply, it will use a string named at reply.
I see.
It's just aliasing it.
Stopping collisions in the data, right?
Yeah, well, and sticking to the allowed format of the schema because I can't start a name with at.
Right. Yeah, fair enough.
It's always something. It's always fucking something.
There's some places where binaries are not by reference.
There should be nowhere that binaries are by reference because of the fact that, remember I said there were two sleight of hand things I did? The first was address, the second was binary. Binary is a raw link. And so by being a link itself, that's why there's no and in front of it when it's called, because it is a link.
Okay, I see. So it's like something that immediately resolves to whatever blob of data that sits underneath it.
Yeah. But I had to lift it one layer up because I still need to make all the classes have their same interface where I can call crush. And crush, it allows me to use these classes while I'm doing work on them. And then when I call crush, it generates all the links and does all the hashing and all that. Binary needs to still fit that interface, otherwise I'm like, except if you're binary, take this different path. So it's made to fit that interface, but it is already crushed. It cannot be modified. It is already a CID.
Wait, so what I'm saying, what I'm hearing you say, link is not actually in this case, you're actually referring to the hash only, right?
When
like you call it a binary.
That's what a link is. That's what a link is. And a binary in this system is a link.
Right. You have to have uploaded it before you start interacting with it, basically.
Absolutely.
Yeah.
You have to
create I think that's fair.
Yeah, it works great. Well, in my head anyway. And yeah.
Works great in your head.
But look, I mean, I'm really pleased with it, and you know, what I'm hearing from you is you're sort of not smelling anything that's like, oh, that's off. It just sounds positive. Um,
No, I mean, like, look, to me, the ultimate test in any of this is like, are the types flat? Like, do I have, like, if I can read through a list of like 4 or 5 keys in the type and kind of loosely understand right away,
right,
like what they do, and not see like a ton of like nesting from that,
right,
then that
right,
means
yeah.
that like you've kind of pulled everything apart at the top level, and like it feels like that right now, like much
Oh,
more than
good.
I've seen any previous implementation.
What
You
are we
know,
up to now?
there's some
Like number
places where
13 or something?
there's some places where there's some type nesting, but it looks to me like just roughly that doesn't go a lot deeper than like 2 or 3 levels.
Yeah,
Um,
and they're very simple too. They're the like I could have flattened them more, but it seemed more expressive to nest.
yeah, and I just like it. I think it's really good. I think it's really good. It feels like actual progress on so many questions.
So many, right?
So,
Like so many things that we just punted down the road, like later, 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 and then it's like, this is kind of. I honestly don't have any unanswered questions about the blockchain system now. Are there
I,
anything?
I I mean,
What?
the one for me is pretty much just have you made any special exceptions to privacy checking, or is it still chain ID and pub key? Like, because there is a layer in here that hasn't been written yet, which is when I go to load the pieces that I'm loading from other
Yeah.
chains, like I need to do a check, right?
Yeah. So yes, it's still absolutely chain ID and pub key, and I'm convinced it can't be any other way. And so the um, chain ID plus pub key plus path to lookup is, I think, all it can be, and that definitely belongs as an IPFS layer module. That
Right.
is not. That is. It's an operating concern. It is not the structure that is laid out here need only be concerned with things like metadata leakage between channels to different chains, leaking the randomness, things like that. That's what this structure needs to be concerned about. The access control decision is thankfully, I believe, an entirely different independent problem.
Right. Groups
Um,
have access to what
so is
paths and what action.
so is discovery and like retrieval, transport.
Yeah, discovery might be. I mean, discovery is always weird, but that's what the internet's for, right?
Haha, discovery is fun. Um, so one of the there's this concept of the app root for any chain complex, and
Yeah.
when there's a new this is one place where the structure sort of is designed to tie in with the communications medium, but also sort of not, like it's a nice consequence. So the idea is deep down in the chain complex, there's a new pulse gets made. Because of the rule about the bubbling up of the state tree, it then needs to tell its parent, which makes a new pulse. It tells its parent all the way up until ultimately the app root makes a new pulse. It is the app root that is listened to as a topic throughout all the subscribers. The app root is the only announce that says, hey, new pulse. If you are listening to a deeply nested child, you don't get to listen to it directly. You only get to listen to the app root telling you there was a new app root, and you then use the app root to walk to get to the chain you wanted.
Right.
So that takes down a whole lot of noise in the network layer, you just can't subscribe to millions of chains. Like it doesn't, you'd fall over, the network would die.
Right. I mean, that's like basically almost the same thing as a NIC, right? Like this middleman that's actually talking to all the pieces that are running on the machine that like turns it into packets that go over the network.
Yeah.
But it's better because it's basically got built in like an ounce pub sub kind of stuff.
Yeah. But the uproot concept is also important for validation. When you go to make a new, that's why I'd included it at the top level in the DMZ, because when you go to make a new pulse, the validators are responsible for inserting the latest uproot pulse as well, and they should reject a proposal from anyone who's using a stale uproot, because it should be pretty fresh. And what that means is that any cross-chain queries or any reads across the chain during that block making cycle were done based on walking from that version of the uproot down. So it gives you consistency across a huge complex of chains that are all changing simultaneously. The uproot is the point of synchrony between them all, so that you can deterministically replay what cross-chain reads were done at any given block making event.
The chain complex. Another name for like a set of complex things that are long, linear, is a braid in math.
A braid.
Yeah, because it's basically like a bunch of chains wrapping around each other in a bunch of like unpredictable ways, right?
Yep.
That's my stupid profound thought for the moment. Yeah, I mean, I honestly don't know what else to do right now. I'll like read it deeper and let you know if there's any more to it.
Yeah, if you spot some errors or you want to make some changes or you got questions, hit me up. I mean, this we basically couldn't be too thorough on speccing this very doc. I will continue building the model system around it. I don't mind changing the model system to fit as the doc modifies, so that's all fine.
Right.
I think for the first time, I feel like this is the system. This is the one that we can get to public with.
Right.
It seems so much simpler than any system before, and yet so much stronger in so many ways.
Yeah, it really does.
Yeah. Okay. Well, I guess I'll carry on.
Sure. I'll read it. I'll let you know if I have any more thoughts. Okay.
Okay, sounds good, man. Thank you very much for taking a look at it and reading through it. It's yeah, it's great to be able to talk about it.
For sure. Yeah. Have a good one, man.
Okay, peace. See you.